Okay, here's our problem 17.2 from the Pearson lecture. We're going to solve this in two different methods, the first being the equilibrium method and the second being the Henderson-Hasselbalch method. We're going to start by writing out an equation for the first one. Hydrogen cyanide plus water goes to hydronium ion plus cyanide ion. We're going to write an ice table. Hydrogen cyanide, hydronium ion, cyanide ion. The initial values 0.250 molarity, 0 and 0.170. The change here, we put negative x, and plus x. Then we get this as the final. Over here we have our values as we put into the table. Ka value 4.9 times 10 to the negative 10. And now we have our Ka equation. Ka equals products over the reactants, which from our equation here we get this. So we plug in all the values. Here's your Ka, then here is your products and reactants. And a key note here, when the Ka value is small, the X is also very small. So essentially 0.170 plus X is roughly equal to 0.17, and 0.25 minus X is roughly equal to 0.25. So now we just sort of plug things back in. I went ahead and plugged the hydronium ion. The hydronium ion back in to the equation. So we ended up getting a value of 7.21 times 10 to the negative 10. Next we move on to the pH equation. pH equals negative log of the hydronium ion. So it equals negative log, negative log 7.21 times 10 to the negative 10. And that gives the pH value of 9.14. Next, we move on to the Henderson-Hasselbalch method. Here is the equation for that. pH equals pKa plus log over, log to the base over acid. pKa value is 9.31 for the hydrogen cyanide. So we simply just plug in our numbers, 9.31 plus log 0.17 molarity over 0.25. And we just put this in the calculator and the answer comes out to 9.14, just like above. That'll be it.